Hi everybody. Here in Excel I have to make a 3D plot using 3D range of data table to be created like this one. And using this data table I have to do a plot, 3D plot like this. Then using first partial derivatives of the function of two independent variable like this equation, I have to find the stationary point, I mean the value of x and y, and as well need to find the value of z. And then using second partial derivatives and satisfying defined conditional expression like this one, I can determine and locate the minimum points. This red circle, this is the minimum points. To find a maximum points like this circle. Also here the saddle points as showed here by red circle on the 3D plot. Now I am going back to my first spreadsheets. Here I have to make a 3D plot. In other way I can say a graph of function of z equal to function of xy. Actually it is an equation of two independent variable x and y. As an example, I have taken an equation as z equal to function of xy equal to 4x square plus 3y square plus 2. If we look at right hand side of this equation, we can see two independent variable x and y. But z is dependent variable as its value depend on x and y. Now before making a 3D plot, first I have to make a 3D range of data table to be composed of x values, y values and z values. On these sheets, x values are from -2 to +2 in the horizontal direction, which is represented by red arrows. And in short I can say x less than equal to 2 but greater than equal to -2. In the same way, red arrows is in the vertical directions to represents y value from -2 to +2. Also in short I can say y less than equal to 2 but greater than equal to -2. And z values are with an arrow, we can see it here, towards in this rectangular area, and these areas cell value, I mean the value of z, will actually be generated by Excel using formula like this. Now I have to get z values. As its value is dependent on the value of x and y, so in the first cell, this one, I shall put a formula as like this. To make this formula, I have to be careful of considering number 5 rows cells and B column cell value, this line. That's why I have to use dollar symbol before number 5 so that I can use C5 cell value, this minus 2, from C6 to C14. Again, I have to use dollar symbol before B. Here you can see that. So that I can use B6 value, this minus 2, from C6 to K6. Now question comes, how to do that? First, I copy this cell. Then highlights whole area. Pressing enter. Right away, whole 3D range of data table appear. Because C6 cell formula, this one, C6 cell formula pattern is applied to each cell. I mean all this triangular area. This C6 cell formula pattern is applied. And Z values are automatically generated by Excel. To validate that, in column C, if I click in cell say C7, it is showing C5. On C9, it is showing C5. Again click on C14, it is showing C5. Again in number 6 row, if I click in the cell say D6, it is showing B6. Again if I click on F6, it is showing B6. Again if I click on H6, it is showing B6. Now the cell formats which allow us to change the way cell data appears in the spreadsheets, and it helps us to change. So what we'll do? We'll go to the format. Here if we click on format, then format cell, then here borderline. We can customize cell data format. Once I finalize 3D range of data table, I mean this one, then I shall move to create 3D format of graph from insert. So before going to insert, I have to highlight this rectangular area. Now if I go on insert, clicking here, I get more line charts. Then on surface, I got this. So this is our plot. So I got this 3D graph. Now I put it in right place. The surface chart has different colors. We can see it here with coding as this line. Here with different range with different color. Say 0 to 10 blue color. You can see it here. 10 to 20 this color. We can see it here. After that, I can customize 3D plot using 3D rotation. Selection of data, format plot area as well. I can customize major and minor grid lines. How it comes? First, right click on the graph. Then clicking on this format plot area. This one here, 3D rotation. Here 3D format, actually I am not using, but for me 3D rotation is important for optimizing graphs because it helps me to get a distinct curvature and looks for the 3D plot. So I do use it by using proper angle of rotation and angle of perspective. Such as if I use X rotation, say 40 degree, and Y rotation 15 degree and perspective 15 degree, then I can see, later we will see that we will see the full length of x-axis and y-axis value from this minus 2 to plus 2, this minus 2 to plus 2. And after customizations, it will be clear. So I put here 40 degree, 15 and 15. Again, I do right click on this and I select data. This one. Here what I will do, here I shall edit this x value, this one, this x value from, I shall change this x value to this minus 2 to plus 2, and this series 1 to series 9 I shall edit this to minus 2 to plus 2. How I will do that? Suppose first I will do this one. So here I put click and I click here, this already changed. Then for this side, from series 1 to series 9, I will do a step by step. Say series 1, edit, I will select this, it is done, -2. If I click on say 4, so 1, 2, 3, 4, I'll click here. So it is done. If I click on C9, edit, this last one, it is done. So I can change all this series to -2 to +2. Now here, if I click on this plus, I can see here axis title. I don't have that. So if I click on it, right away axis title came. So I can put chart title, I can put axis title, I mean Z axis, this is X axis as well. I can shift this, I can put here Y axis. So I can do customizations. Here it is more clear. Already I did here X axis, Y axis and Z axis. Already I showed that I used rotation 40 degree, 15 degree Y rotation and perspective 15 for getting this X axis value from -2 to 2 and Y axis value from -2 to +2. That's what I got. Now I can do measure grid lines. How to do that? Here, or I can go in other way, clicking on just, suppose I want to click here, I want to click on Y axis. So clicking on here, add measure grid lines. Already I got it. Again clicking on this, I mean X axis range, add measure grid lines. Already I got here. So we are done with the 3D table data and 3D plot. Then I am showing how to use first and second partial derivatives of the function this one of the functions of two independent variables for finding the stationary points, the value of z, which in turn helps me to find the minimum points and then this maximum point and then this saddle points. Once I get these points, then I can locate minimum point, maximum point or saddle point on 3D plot. Here I am showing first how to find minimum point using first and second partial derivative, as well using this expression. First I have to find a stationary point using derivative del z by del x equal to 0, del z by del y equal to 0. Doing first partial differentiations of equation z equal to 4x square plus 3y square plus 2, we get del z by del x equal to 8x and del z by del y equal to 6y. Now, equating 0, I mean 8x equal to 0 and 6y equal to 0. So right here we get x equal to 0 and y equal to 0. And putting the value of x and y in this equation, I get z equal to 2. Now, if we do second partial derivatives, then it takes the form like this. Del square z by del x square equal to 8, del square z by del y square equal to 6 and del square z by del x del y equal to 0. Here keeping y constant, here keeping x constant. Now substituting these three values in this expression, we get it 48. It is greater than 0. Again del square z by del x square equal to 8 equal to greater than 0. Then we can go to this page. Here we can see three conditions. Nature of a stationary point is determined by if this expression less than 0, saddle point. If this second line greater than 0, this is minimum point. That's what just now we get this one. And this one greater than 0 but less than 0. Now we go back to our sheets. Here it is showing greater than 0, the second condition. So this stationary point 0, 0 is a minimum point at z equal to 2, what we got here. Now if we locate this point, it is here and this is minimum point. Why? If we were to move away from this minimum point in any direction but remaining on the surface, the value of the function would increase. That's the main point here we need to understand. Now if we look at this page again, we can see here this greater than 0, this less than 0, maximum point. So here already I did the graph as well the 3D data table using this equation. Here also I calculated stationary point, z value and second partial derivative of this equation as well. Putting this value in these expressions, I got 48 greater than 0, but del square z by del x square, it is minus 8, it is less than 0. So if we go to this page, we can see third lines. Less than 0, greater than 0. So it satisfies these conditions. So it is a maximum points. So this is the So the stationary point 0, 0 is a maximum point at z equal to 3. We can see it here 3. And we can locate this maximum point here. If we were to move away from these maximum points, this way, that way, or in other way, but remaining on the surface, the value of the function would decrease. Again, in other spreadsheets here, I used this equation. Here also, I use this data table and I found this stationary point as this, z value as this, like before. Then second partial derivative, I got this value 0, 0 and 2. So putting this 3 value in this expression, I mean if we go this page, this first one, in this expression, less than 0, saddle point. So we are coming back here. So it is less than 0 because minus 4. So these stationary points is a saddle point at z equal to minus half. We can see it here. Now, if we locate this stationary point here, I mean as a saddle point here. So when leaving a saddle point in one directions, the value of function decrease. Again, if we leave in the perpendicular directions, the value of the function increase, and intersections of these directions and these directions is this point. This is the saddle point. And that's all for today. Thank you very much for watching.